This is MSJ Chem. In this video, I'll be looking at the activity series. The activity series lists metals in order of their strength as reducing agents. Metals at the top of the activity series are stronger reducing agents. They are more readily oxidized. This means they have a greater tendency to lose electrons. Metals at the bottom of the activity series are weaker reducing agents. They are less readily oxidized. This means they have less tendency to lose their electrons. The full activity series can be found in Table 25 of the data booklet. Here we have the metals at the top of the activity series. The metals at the top are the strongest reducing agents. And here we have the metals at the bottom of the activity series. Metals at the bottom of the activity series are weaker reducing agents. Metals higher up in the activity series can reduce the ions of metals below them. In this reaction, magnesium is reacting with aqueous copper sulfate to form magnesium sulfate and copper. Here we have the net ionic equation for the reaction. If we look at the oxidation states, we can see that magnesium has been oxidized and the copper 2+ ions have been reduced. In this reaction, the magnesium has reduced the copper 2+ ions. That's because magnesium is a stronger reducing agent. Next, we look at displacement reactions. If a piece of zinc is placed in an aqueous solution of copper sulfate, a displacement reaction occurs and the copper 2+ ions are displaced from solution by the zinc. In the reaction, solid copper metal forms on the piece of zinc. Here we have the equation for the above reaction. If we look at the net ionic equation, we can see that zinc has been oxidized and the copper 2+ ions have been reduced. The zinc has displaced the copper 2+ ions in solution. We can also say that zinc has reduced the copper 2+ ions because zinc is a stronger reducing agent and it's higher in the activity series. In the previous slide, we saw that zinc can displace copper ions from solution. However, if a piece of copper is added to an aqueous solution of zinc sulfate, we get no reaction. And the reason for this is that copper is a weaker reducing agent and it's unable to reduce the zinc ions from solution. Let's have a look at another reaction. If a piece of copper is added to an aqueous solution of silver nitrate, the copper displaces the silver ions from solution, forming copper nitrate and solid silver. In this reaction, the copper displaces the silver ions from solution. The copper has reduced the silver ions because copper is a stronger reducing agent. It's higher in the activity series. In the second equation, a piece of silver is added to an aqueous solution of copper nitrate and we get no reaction. This is because silver is a weaker reducing agent and it's unable to reduce the copper ions in solution. Let's end with a summary. More reactive metals are stronger reducing agents and are found at the top of the activity series. Less reactive metals are weaker reducing agents and are found at the bottom of the activity series. More reactive metals can displace the metal ions of less reactive metals from solution. And finally, more reactive metals can reduce the metal ions of less reactive metals in solution.